Okay, hello everyone, and welcome back to the new module of Introduction to Neural Network. So let me share my screen and keep going. Okay, so by end of this lesson, you will be able to describe and explain neural network structure and also taxonomy words, and you will be know what called in each network, what are these nodes, what are these lines, how do the neural network do the calculation, why neural network called a deep learning, and what are the different types of neural network. For step one, we will start from the basics, okay? So far in the course, we learned the basic and classical machine learning. So classical machine learning models, we learned so far that they are in the two major groups, supervised machine learning and unsupervised machine learning. And you learn that the difference between the supervised version versus the unsupervised machine learning is supervised machine learning, you are dealing with labeled data. So you have bunch of data that you have a specific label on that data point. If it's a classification, you, for example, label the image as a dog or a cat. You label your data point as an accurate data point or false data point through false classes. So you're dealing with different classes, and that calls classification problem, right? So we had also discussing the discussion of the regression models when you are doing a prediction of the numbers. You have different input features, and then based on those input features, you want to predict a value. And then we use different algorithms on the supervised machine learning to deal with those problems. At the same time, in the another module, module 4, we discussed the unsupervised machine learning. So unsupervised machine learning problem is when you do not have any specific labels on your data set, and you try to cluster data, you try to do some pattern identification, or you want to reduce the dimensions. So we discussed all those topics. So far, this was the picture. So when you are dealing with the machine learning problems, it could be a supervised machine learning model, it could be unsupervised machine learning model. And it depends whether you have a labeled data or you do not have a labeled data. Now, in this lesson, we will start another group of AI models, which is called deep learning. And the reason that's called deep learning and why the module is named neural network, you will figure out it very soon by end of this video. So one of the problems, if you remember when we started the machine learning module and discussed developing different machine learning models, was the interaction between the features. So if you recall, in some of the examples that we did in the class, so the problem of correlationship or any kind of relationship between the features was a very critical task, yes? So you did all the analysis, you try to figure out whether is there any relationship between your features. And you remember that machine learning model problems, the challenge that they have is they cannot very well understand the interaction between the features. That's why we have the deep learning, and that's why we have the neural network. The major goal is to understand how these different features could interact and capture that interaction. So let's look at one problem. So we discussed this problem also in the machine learning module. So we have different people. We have their banking information background, if you recall for the example from the example that we discussed in the module machine learning. And we want to see each person based on the background of that person, how many transactions per account, bank transaction they make. And then if you recall from that example that we did, so we had the age of the person, we know how much money that person has in the account, we know the retirement status of the person, whether that person is working, what's the job title, and we have a lot of other information. And then we start to study the problem by doing a supervised machine learning. So if you remember from that example, How did we do this machine learning example? So we consider all those features. We try to see whether is there any relationship, any correlationship between your input features. And if it is, we decide and include some of the features. And then how we learn the problem was, how we solve the problem was that we apply the algorithms, and then the algorithms fit it on the trained data, and then we use it for the test data, right? That was the problem, right? Each of our features is connected to the dependent variable, the variable that we want to do the prediction for. But for the deep learning, for the neural network, the difference is, so all of those features now are playing as your input layer. So you have a different layers in your neural network, and each of your node, this is called node, each of your node in the input layer represent one of that features that we discussed. For example, back into the a transaction problem. So this is the age. So that's one features. That's input feature of your data points. You know that this person is 25 years old. We know that this person have 10K in the account. We know that this person is working, and we know that person job, and many, many more features. But now in this neural network setup, so you can understand and capture the interaction between the features. So why? Because all of the features are connected to the new node in the next layer, which that node number is calculated based on this number. So I mix the age, the bank balance, retirement status, job title, and get one number here. I get another number here. And then the final goal is, after you have different layers, after you have different calculation, your optimization process will give you the number of the transaction based on all of the input features. You're back to the age, you go back to the bank balance, retirement status, job title, you have all those as numbers, you interact those numbers, and then those numbers finally together give you the output layer. This is called output layer, the number of the transaction. So the problem include input layer, hidden layer, output layer, and all of this called nodes, right? So this is the basic of a neural network. Input layer, hidden layer, output layer. And all of those are nodes. And these are your input data point. And these are the calculation that you complete. And then this is your output number, which you are going to predict that number. So I don't want to go in the details, but right now we just learned the language. So as I mentioned, the process that we do the calculation, when we do the forward calculation, is called forward propagation. What's that? We'll delve into details in the next video. For now, just remember the process of getting from the input layer to the output layer. When I mix these numbers on my nodes, this calculation is called forward calculation. So you do the forward calculation. And the question is, how should we do that calculation? Right now, I'm not going to details of the Python programming code, but we will do that in the next module. So it's very easy. You can just look at one example here. So just imagine this is a hypo example. So my input here is 2, my input here is 3. The weight on this line is 1, and the weight on this line is 1. Can you guess how this number 5 is calculated? 2 multiplied by 1 plus 3 multiplied by 1. And then it gives us the number 5. So that's a forward calculation. If you look at this node is derived back from this number and this number. And we have the weight 2 here and weight -1 here. 5 multiplied by 2 is 10 plus 1 multiplied by -1, which gives you the 9. So this is the forward calculation. So if you look at this example, there are some important items. One is the number on each of these arrows, which is called the weights. You will see that. So this is called the weights. when we do the calculation of a neural network, the goal is to get these weights. How should we do that? We will see in this module. And the second point is, why 5 multiple 2 plus 1 multiplied by -1? Why not another formula for this calculation, right? That formula is called activation function. And that's the entire neural network language. You have different layers. You have nodes. Nodes are connected. You do the forward calculation. You do the backward calculation. This is called forward calculation and backward calculation. You optimize your network. And the goal is when you have your input data based on these numbers, you can get the best value close to your output layer, which is your goal, right? So this is the question that in this module we are dealing with. So how should we decide on the neural network architectures? How many layers I should have? How many input nodes I should have? And then the second question is formula for the calculation. What activation, that's called activation function. What activation function we should use, right? And then here is one mathematic example. I don't want to make it complicated because it's not for now, but just look at here. This is the previous time we said that 2 multiplied by 1 plus 3 multiplied by 1 give us number 5. Now we have a different formula. 2 multiplied by 1, 3 multiplied by 1, then tan h of that number is the new value of this node. You use a different formula for your calculation, which is that number is your activation function. So you now have this tan h5, but whether using a tan h as the formula helps or not, that's something we'll figure out soon. Or this is another famous activation function, ReLU function. If the value is more than 0, then the value will be equal to the same value you got. But if it's then less than 0, you will get 0. What does that mean? So that means, for example, 2 multiplied by 1, 3 multiplied by 1, if you add those numbers, give you 5. And then you put number 5 here. But just assume that this be -1 as the weight of this arrow. Then we do the calculation for this node, 2 multiplied by 1, then plus 3 multiplied by -1, which gives you -1 in total. Then you are not going to put -1 here because you apply the ReLU function as your activation function. Then it will give you 0 here. Why we do that and how we should figure out what's the best activation function in the neural network. I know that you are now have a lot of question in your head that why we are doing this. You understand that neural network goal is to capture the relationship of the features, but why we do this different of numbers on the arrows and how we do this calculation and why this is called deep learning? The answer is because if you have multiple layers, then this become a deep neural network. And that's why it's called deep neural network called deep learning. And we will get back to all these numbers. But for now, let's go to the assignment 1, which you will learn more on the basics of the neural network. What are the nodes? What is the layers? How many hidden layers we can have? What is activation function? And how all this calculation is completed. And don't forget that deep neural network and neural network can do both classification and regression problems, similar to the machine learning problems. I now ask you to go ahead and do the in-class assignment 1 using this neural network playground to get some insights that we will use that in the following video. See you soon.